Welcome back. Is a good problem. See here, it is a 1/4 of circular path is placed in vertical plane. There is a small sleeve of certain mass m. By applying three different forces in displacing the sleeve from A to B, how much work is done by different forces? Here, force 1 is act always directed from A to B, and force 2 is act horizontal direction, force 3 is act along the tangential direction of this arc. Now suppose it is small displacement is, see, from A to B the total angle is 90, and but with horizontal it makes an angle of 5/4. Similarly, if you take the total angle is 2 theta, this force is make an angle theta with this direction of the F1 with the tangent. See, because initially for this tangential direction this force makes an angle of 5/4. Similarly, with this tangential direction this force makes an angle of theta, then it will becomes 2 theta. And here then you can write S of this displacement is equal to r theta, and effective theta is, the total value is 5/2 minus 2 theta. By differentiating it once, ds is equal to r minus 2d theta. By substituting these values we can get the ds formula. Now the amount of work done by force 1 is f ds cos theta. Here angle between force and displacement is some theta, a displacement and force is theta. Now so here f1 magnitude is 20 is given to us, and here ds is minus 2r d theta, and it is cos theta. So here it is cos theta d theta. By substituting this proper values, 20 into 2 40, r is 6, so it is 240, and after integration of this cos theta we get minus sin theta. Sin theta, it is minus as usual, and remember the angle will be changes. Initially 5/4, when the particle is come to this point, on reaching here the angle between those two tangent and the force is 0. So theta value varies from 5/4 to theta 0. So here I am applying the limits 240 minus and upper limit 0 minus of sin 45 1/√2. After solving this one, we get work done by first force is minus 120√2 joule. Next, work done by force 2 is, this force is always act in horizontal direction, so horizontal displacement is radius. So here work done by force 2 is fs cos 0, force 30, displacement magnitude horizontal direction is 6, cos 0 1, so it is 180. Work done by second force is 180 joule. And see, here force 3 varies as 15 minus 10s. For that one, see, work done by force is fs cos, both are act in same direction, so cos 0 means 1. So here the magnitude of force is 15s minus 10s into ds. After integration it will becomes 15s minus 10s square by 2. By substituting the proper values of this r from 0 to the total distance, path length is given by pi r by 2. By substituting these values we can get, for first part is 141.3, second part is 1.3, 443.68, and after getting solution we get as work done by third force is equal to minus 302.38 joule. This is the total work done by the different forces in shifting the sleeve from A to B in vertical plane. Thank you.